Download this code from codegive.com, link in the description below. Application error, a deep dive into client-side exceptions. When building web applications, encountering errors is inevitable. One particularly cryptic message you might run into is the generic application error, a client-side exception has occurred, or variations thereof. This message indicates that something went wrong within the user's browser while running your JavaScript code. The frustrating part is that this error message itself often provides very little information about the cause of the error. This tutorial will explore the common causes of client-side exceptions, provide strategies for debugging them, and offer practical code examples to illustrate different scenarios. We'll cover 1. Understanding the fundamentals *****. What is a client-side exception, why do they happen in the browser? Common causes ****, a comprehensive overview of the typical culprits. The importance of debugging ***, why addressing these errors is critical for user experience and application stability. 2. Debugging techniques ****. Browser developer tools ***, mastering the console, sources panel, and network tab. Error handling ***, using try, catch blocks strategically. Logging ***, implementing effective logging mechanisms. Source maps ***, connecting minified code to the original source. Debugging libraries ***, leveraging tools like console.trace, and debugger. 3. Common error scenarios with code examples ***. Type error ***, working with incorrect data types. Reference error ***, using undefined variables. Syntax error ***, invalid JavaScript syntax. Range error ***, operating on numbers outside the valid range. URI error ***, invalid URI encoding/decoding. Network errors ***, problems with fetching data from the server. Asynchronous errors ***, dealing with errors in promises and async/await. Framework specific errors, React, Angular, Vue. A brief overview of common patterns. 4. Prevention strategies ***. Code reviews ***, catching errors early. Lintus and static analysis ***, identifying potential problems before runtime. Testing ***, writing unit and integration tests to ensure code correctness. Defensive programming ***, handling potential edge cases and unexpected inputs. 1. Understanding the fundamentals. What is a client-side exception? A client-side exception is an error that occurs within the user's web browser while executing JavaScript code. Unlike server-side errors, which happen on the web server, these errors happen within the user's machine. This means the user's browser is trying to run your code, and something is going wrong that prevents it from continuing. This can be caused by bugs in your JavaScript code, problems with the user's browser environment, example browser extension conflicts, or issues with the data your code is processing. Common causes ***. Here's a breakdown of the common culprits behind client-side exceptions. JavaScript errors ***. This is the most frequent cause. It includes type error ***, attempting to perform an operation on a value of an incorrect type, example calling a method on a null object. Reference error ***, trying to use a variable that has not been declared or is out of scope. Syntax error ***, having invalid JavaScript syntax in your code, example a missing semicolon, incorrect use of keywords. Range error ***, exceeding the limits of a numerical operation, example trying to allocate a very large array. URI error encountering issues while encoding or decoding uniform resource identifiers, URIs. Eval error related to the use of eval, less common and generally discouraged. Network errors issues when fetching data from servers or other resources. CORS, cross-origin resource sharing, errors the browser blocks requests to different domains for security reasons. Timeout errors requests taking too long to complete. Connection refused the server is unreachable. 404 not found the requested resource doesn't exist. 500 internal server error the server encountered an error. Asynchronous errors errors that occur within asynchronous operations, example promises, async/await, set timeout callbacks. These are often harder to debug because they might not be immediately apparent. Browser compatibility issues code that works in one browser might fail in another due to differences in JavaScript engine implementations or supported features. Browser extensions malfunctioning or conflicting browser extensions can interfere with the normal execution of JavaScript code on a web page. External libraries bugs or compatibility issues in third-party libraries can also lead to exceptions. User input unexpected or invalid user input can cause errors if your code doesn't properly validate the data. Memory leaks although less likely to immediately cause an explicit application error, accumulating memory over time can lead to performance issues and eventually browser instability. Security issues attempting to perform actions that violate security policies, example trying to access local files without proper permissions. The importance of debugging ignoring client-side exceptions can have several negative consequences. Poor user experience uncaught exceptions can lead to broken functionality, unexpected behavior, and frustrated users. Data loss errors can interrupt data processing and lead to incomplete or incorrect data being saved. Security vulnerabilities exceptions can sometimes be exploited by attackers to gain unauthorized access or execute malicious code. Difficult maintenance errors that are not properly handled and logged make it harder to debug and maintain the application in the long run. Reduced application performance errors can slow down the application, especially if they occur repeatedly. 2. Debugging techniques. Browser developer tools Your browser's developer tools are your most valuable asset for debugging client-side exceptions. Here's a breakdown of key areas. Console The console displays error messages, warnings, and log output from your code. To open the console, press F12, or Ctrl+Shift+I on Windows/Linux or CMD+Option+I on Mac OS. Alternatively, right-click on the page and select Inspect or Inspect Element, then navigate to the Console tab. Error messages are typically highlighted in red. Click on the file name and line number associated with the error to jump to the corresponding code in the Sources panel. Use console.log, console.warn, console.error, and console.debug, to print information to the console. Console.table, is useful for displaying data in a tabular format. Sources panel, debugger. The Sources panel allows you to view and step through your JavaScript code. Set breakpoints by clicking in the gutter next to the line numbers. When the code execution reaches a breakpoint, the debugger will pause, allowing you to inspect variables, the call stack, and more. Use the step over, F10, step into, F11, and step out, Shift plus F11, buttons to control the execution flow. Asterisk the call stack panel shows the sequence of function calls that led to the current point of execution. Asterisk network tab asterisk. Asterisk the network tab shows all the HTTP requests made by the browser. Asterisk you can inspect the headers, status codes, and response data for each request. This is crucial for debugging network-related errors, CORS, 404, 500, etc. Asterisk filter requests by type, example xhr/fetch, CSS, images, fonts, to narrow down the search. Asterisk error handling, try, catch. The try, catch statement is fundamental for handling exceptions in JavaScript. It allows you to gracefully handle errors that might occur in a specific block of code. Important considerations for try, catch asterisk. Asterisk specificity asterisk wrap only the code that might throw an exception. Wrapping too much code can make debugging harder. Asterisk rethrowing asterisk in some cases, you might want to catch an exception, perform some cleanup or logging, and then rethrow it so that a higher level error handler can deal with it. Asterisk asynchronous errors asterisk try, catch does not automatically catch errors that occur inside asynchronous operations like promises or set timeout callbacks. You need to handle these errors explicitly, see examples below. Asterisk logging asterisk. Effective logging is essential for debugging, especially in production environments where you don't have direct access to the browser's developer tools. Asterisk strategic logging asterisk log relevant information at key points in your code. This could include asterisk function entry and exit points, asterisk values of important variables, asterisk the results of calculations, asterisk error messages, asterisk logging levels asterisk use different logging levels, example console.log, console.warn, console.error, console.debug, to indicate the severity of the log message. You can then filter the log output based on the logging level. Asterisk logging to a server asterisk consider sending log messages to a server-side logging system. This allows you to collect logs from all users and analyze them centrally. There are many logging services available, example Sentry, Rollbar, LogRocket. Asterisk source maps asterisk. When you deploy your code to production, it's common to minify and bundle your JavaScript files to reduce file sizes and improve loading times. However, this process makes the code harder to debug because the original source code is transformed into a less readable form. Source maps are files that map the minified code back to the original source code. When you enable source maps in your browser's developer tools, the debugger will show you the original source code instead of the minified code, making it much easier to understand the execution flow and identify the root cause of errors. Most build tools, example Webpack, Parcel, Rollup, can automatically generate source maps. You may need to configure your web server to serve the source map files. Asterisk debugging libraries asterisk. Several debugging libraries can enhance your debugging workflow. Asterisk console.trace prints a stack trace to the console, showing the sequence of function calls that led to the current point of execution. Asterisk debugger inserts a breakpoint directly into your code. When the code execution reaches the debugger statement, the debugger will pause. 3. Common error scenarios with code examples. Asterisk type error asterisk. A type error occurs when you try to perform an operation on a value of an unexpected type. Asterisk reference error asterisk. A reference error occurs when you try to use a variable that has not been declared or is out of scope. Asterisk syntax error asterisk. A syntax error occurs when your JavaScript code contains invalid syntax. These errors are usually caught by the browser before the code is executed. Range error *. A range error occurs when you try to perform an operation on a number that is outside the allowed range. URI error *. A URI error occurs when you encounter issues while encoding or decoding uniform resource identifiers, URIs. Network errors *. Network errors occur when there are problems fetching data from the server. Asynchronous errors *. Handling errors in asynchronous operations requires special attention. Framework-specific errors, React, Angular, Vue. Each JavaScript framework has its own error handling patterns and common pitfalls. Here's a brief overview. React *. Component rendering errors errors that occur during component rendering, example inside the render, method or functional component body, can cause the entire application to crash. Use try, catch blocks or error boundaries, React's built-in error handling mechanism, to handle these errors. State updates on unmounted components Trying to update the state of a component after it has been unmounted can lead to memory leaks and errors. Make sure to clean up any asynchronous operations or timers in the component will unmount lifecycle method, for class components, or using the useEffect hook with a cleanup function, for functional components. Angular Zone.js errors Angular uses Zone.js to track asynchronous operations and trigger change detection. Errors that occur outside of the Angular zone can be difficult to detect. Use Angular's error handler service to catch and handle these errors. Template errors errors in Angular templates, example incorrect property bindings, missing pipes, can cause rendering issues. Vue component rendering errors similar to React, errors that occur during component rendering can cause the application to crash. Use try, catch blocks or Vue's error handling features, example the error captured hook, to handle these errors. Data mutability issues modifying Vue's reactive data directly, instead of using the Vue.set method or the this.$set method, can lead to unexpected behavior and errors. 4. Prevention strategies. Preventing errors is always better than having to debug them. Here are some strategies to reduce the likelihood of client-side exceptions. Code reviews Have other developers review your code to catch errors and potential problems early on. A fresh pair of eyes can often spot issues that you might have missed. Linters and static analysis Use linters, example ESLint, and static analysis tools, example TypeScript, Flow, to automatically identify potential problems in your code before runtime. These tools can detect syntax errors, unused variables, type errors, and other common issues. Testing Write unit tests to verify that individual functions and components work as expected. Write integration tests to ensure that different parts of your application work together correctly. Testing helps to find errors earlier. Defensive programming Write code that is resilient to unexpected inputs and edge cases. Input validation Validate all user input to ensure that it is in the correct format and within the expected range. Null/undefined checks check for null or undefined values before accessing properties or calling methods on objects. Error handling use try, catch blocks to handle potential exceptions gracefully. Type checking use TypeScript or Flow to add static type checking to your JavaScript code, which can help to prevent type errors. Conclusion. Application error, a client-side exception has occurred is a frustrating message, but by understanding the common causes, mastering debugging techniques, and implementing prevention strategies, you can significantly reduce the number of errors in your web applications and provide a better user experience. Remember to leverage the power of your browser's developer tools, write thorough tests, and embrace defensive programming practices. Good luck, and happy debugging.